As usual, let me take a couple of questions before we start. These slides are already uploaded to Avenue. So those who prefer to look into the slides at their end, they will be able to get it from there. I hope you are doing well with Lab 3. And let me know if you got questions for the lab. I cannot get the terminal to show up. Can you give steps, Karina? Yes. So if you weren't able to get it, you have to install it exactly the same way we have done in Lab 0, which is you have to go to help and then marketplace and then type terminal for search. It will give you this one. I guess in Lab 0 we had steps for that. And if you still face problems, please go to office hours. Either me or the TAs will help you with that. I installed in my E drive at the beginning of Lab 0. Is that fine? Yeah, no worries at all. There is no problem with this. But just remember that you would need another Eclipse IDE package for Java, right? So the one we have been using for C is different. So if you have watched my recording for the tutorial, you will know that we need another, I would say, the way we do it right now is we completely download another IDE package for Java, and it's separate from what you have for C. Good. Okay, good. So let's start. So we will continue doing, as I said multiple times before, almost all the lectures will be building on top of each other. Last lecture, we continued our discussion for classes as a third lecture, and we have seen how to use classes outside of, like in another class for testing, for example, in the main, how to define and write methods and how you use these methods and how different methods interact with different classes, how to use the this members as well as the members of the class from another object that you can take as an input. And we have seen how to apply this into the lab questions as well. Good. So today we are going to slightly introduce another thing, another capability that we can deal with in classes, which is how to define a member of a class to be another class, right? So let's see how to do this. So simply this terminology, composition of classes, referring to that you can create a new class that has an old class as a member, right? Or you can use it with the new class. So if we revisit our points class, the one that we have been working on in the past 2 lectures, what we're doing is simply we were writing a class that defines these coordinate points. You can use, for example, for a flight or a car map or anything else, and simply it represents or resembles the Cartesian point of a certain object over time, right? Every object you create has this x and y, which represents the coordinates in x and y Cartesian coordinates. Good. And then we define constructors, setters, and getters, and we also used it last time to define some other methods like distance to, if you remember this one, which takes as an input another object and calculates the distance between the current object and that object that you get as an input. Good. So what we want right now, assume we have this point class, right? One of the main points I discussed with you before is object-oriented programming main point is you have modularity, which means you work in a class, another one in the team works in another class that can use your own class towards building a bigger project, right? So today we are taking one step further towards this, which is assume I already have the point class. Next year, next month, whatever you wanted to use the point class to implement something bigger. This thing that is bigger, let's say, for example, I want to create a package of graphic classes like circles, triangles, rectangles, squares, whatever you prefer, right? So we will start with, for example, I want to write my circle class, right? So if you think of, assume you didn't even previously had this point class, right? To write a class for a circle resembling a circle, remember what we discussed last time is we have the real life use case and we have the OOB representation. We said a real life object would have 2 things, attributes as well as actions. And then in object-oriented programming, you write this also as a class or object where attributes, can someone remind me how can I resemble or model attributes for OOB? How to map these things? Remember last time we discussed the dog-like example in instance variables. I think that that's correct. So you have this as variables. And then the actions will be the methods. Good? So every time you find a problem in front of you, think in this mentality. So assume now I want to, my real life example is a circle. So what do I want from a circle as attributes? What defines a circle in geometry or math is you have a center, right? And the radius. These two attributes are enough to define a circle in geometry, right? Good. Then this radius is simply just can be like a double variable, for example, where this center is required to be a Cartesian point, x and y, right? And here comes the usage of, you remember, yeah, I had another point class before, and I can use it for the center representation, correct? And this takes us to what we want to do today, which is how to use a class inside another class as a member of another class, which is called class composition. So as you can see here, I define the radius as double, while the center is nothing other than an object of the point class. Good. And then simply, is there any question in this modeling? Okay, good. So, so now, as we do in any class, I want to start after defining the instance variable. I want to start thinking in constructors and methods. As I told you before, you should start with constructors, setters, getters, and then what are other methods you need, right? So we have done already the instance variables. What about constructors? I define two constructors here. One of them is only taking the radius, right? And in this case, what you would expect, we should set the center to. If my constructor only takes, 0, 0, and how, that's correct. Initialize it to be the origin. And then the more general one, which is taking the radius as well as the x and y as an input. Good? Perfect. So if I take x and y, simply what I want to do is I want to set the radius, this dot radius, or simply just write radius, both are the same, to r. Now I need to set x and y, but x and y here should be set as a center object point. So I should say center equal new point, because here, remember we said there is declaration and there is memory allocation, right? This is the first lecture we had in classes. So here I'm allocating the memory for the center and initialize this by the bast x and y. While if I only get the r as an input, I create the center class to be 0 and 0 as Jan Hao said. Any questions so far? So almost no new information here. We are using the class point as we have used for testing in the main, for example, to create another point, but just to show you the interaction of how to use it as a member of another class, right? That's the main point. And if you want to initialize things, how to call this, if you want to get the values, as we'll see right now, of x and y, what to do, right? Good. So today's lecture is very simple if you understand the previous lectures. So after constructors, I told you you need to do setters and getters. So I assume I want to write get radius, get x, get y. Maybe a good practice is to really do this in the online GDB. So let's see here. Yeah, so here I have the main, which we are going to test our two classes in. This is the point class. So that's just the simple implementation of the point class. Maybe later I can take the distance to implementation. And this is the constructor. This is the set. Okay, and these are the getters. Good. So this is the points class. And then maybe I should add another file. And I call this my circle dot Java to model the circle class, right? For the circle class, just take the template here and then we discuss it together. So simply these are the two instance variables we have been discussing. Then the first constructor, which is this one, this is the second constructor. Both are creating the main point we are highlighting here is this, which is using the point class inside the circle. And now I want to implement these methods. Assume, for example, I want to get radius. This is pretty simple. We have done multiple times before. Can someone kind of guide what should I write here if I want to just return the radius? Again, when implementing constructors and instance variables, I want to look into setters and getters, right? So first of all, getters. Those getters and setters have to be public, as we discussed before. And for getters, I'm returning the member variables to the user asking about them. So return this to radius, that's correct. Or you can even return radius, that's also correct. So you can say return this dot radius, or you can simply write return radius as well from our discussion of the this, right? And then for X and Y, here comes the interesting part, right? So the first thing is you don't have X and Y as, so look into this two instance variables or instance members of the circle class, my circle class, they don't have X and Y as members, right? So I cannot just say return X or return Y, right? I have to go through another black box, as we will visualize right now on the slides, to get the X. So think about what we have discussed before. How can I do this? Any idea? My circle dot X, but Sarah, so is my circle has X member, right? This is the main point, right? So look into the my circle class. It doesn't have an X member. So if you say my member, my circle dot, that means you should refer to a member of the object you are writing or the class you are writing, right? But X is not a member of my circle, right? Point.x, but point is a class name, so I cannot refer to X as point. Center.x, Katie, you are close. That's good. Center is an object. But then remember, we defined X and Y to be, so you guys, those are returning center.x or return center.x. Perfect. So then Mark is getting closer and Yan Hao as well. That's good. So circle.x is logically correct because X is a member of circle. But remember, X was a private member, right? So you cannot just directly refer into it. You have to use the getter and the, in this case, you have to use the getter, but generally the getter and setter interface to access the private members of a class. So the right way is to say return, and then here I have my center, which is an object, and then this object has the getX method that gives me X, right? This is exactly how you should write it. So can I write this center.getX? For sure, that's correct, because center now is a member of the current this class, right? And then Y would be exactly the same thing. Is that clear? Because that's one of the things that, like the main point behind today's lecture, or class composition in general, how to differentiate between different members of different classes you use and how to access them. So is there any question related to this? Okay, you guys all good. So that's perfect. Yeah, center.getX, that's correct. Good. Yeah, thanks everyone. Good. Then let's can I write, so let me ask a question. We have dealt with X and Y as separate entities right now, like your X and Y coordinates separately of the object center. But really, I can also refer to the center as a whole, right? Which is an object. In this case, this is a member of the MyCircle class. And in this case, I can just say return and then this, or without this, and then center, right? So, well, if I do this, I have to return a class because center is really an object, or I have to return an object of type point. And this is why here you have the object you return is point, right? We have seen this also in the lab, in the tutorial, where you want to return a matrix from a class. So, sorry, from a method. So simply a method can also return a class. And the mentality behind this is you can think of the class as any other type, but this is a type you define, right? So since you can return int, you can also return point class, right? And in this case, you return this to center. Any question? Okay, good. Then after, so the logical thinking is how to map real life into a class. And then you discover, oh, I can reuse another class that I have wrote, which is one of the good things about OOP, code reuse. And then once I put my circle class together into writing, I want to start with instance variables, constructors, setters, getters, and then, as we said, the last step is what are the actions you want, right? What are the methods that really can increase the benefit of the class you write. So here, assume we want to write, so forget about this main thing. That's wrong. Oh. So one of the methods we can write is we want to determine whether two circles are tangential or not, right? And what do we mean by tangential circuits? Let's go back to the slides, but first I might look into questions. Yanha, what should you do if you want to print get center? Okay, so we will see it now when we go to the main writing the testing. We didn't do this yet, but how to use get center will come into it. What were the setters for this class? Yeah, that's a good point, Katie. We didn't write the setters, but simply if you want to set the values, you would have to write also three. Simply you can write 3 or 4. Maybe you're not. I should. Yeah, I might try to do this with you now. So let's say these are the getters. What about the setters? Setters are void because they return nothing. And here, let's say set radius. What I want for set radius, I want to take radius as an input, right? So I'm here taking, this should be double, and then R. And then simply should set this dot radius equal R, right? So this is simply setting the radius variable. What about X and Y? Let's do one of them. The other one would be exactly the same. So public void set X should be, I should take int X. And in this case, again, we have to be careful. I should say this dot center dot set X equal X, right? So again, similar to the getter, which is here, I refer to the center object, which is member of the circle, and then I use the get X interface to access X. Here I'm using the set X interface. The same thing should be for the Y. Now let's look into the case that might be interesting, which is, can I write something like the following? Set center, and then I take point point class, let's say my, or C, like I just going to call it C. And then now I take a point as an input and I want to set it as my center, right? One way to write this, now I'm going to have, in fact, this was something outside of this lecture, but it's good to discuss. So I'm going to write it in 2 different ways, and let's discuss what are these ways. First of all, I know that point C has X and Y. So simply what I can write, which is a straightforward way, says this dot center equal, sorry, dot set X equal C dot get X, correct? And then the same thing exactly for the Y. C dot get Y. So that's the safest way, straightforward way, and good. Now let's discuss another one, and let's see if this makes any difference to you. Can I say something like this? Dot center equals C. What do you think? Yeah, what do you think? Like, can I write something like this? This dot center equals C. And what does this really mean? And does this achieve the functionality we want, right? Simply C is a point class, right? Here, C is a point object, sorry. And center is also a point object. To see whether this works for you or not, you have to go back to the rule, which is assigning an object to another object what does this do for you, right? What do you think? Is there any input? Any guess? Remember, we discussed this in one of the very first lectures about classes. So simply, if you assign an object to another object, you make the second one reference exactly the same memory as the first one, right? So in the memory object, if you make object 1 equal object 2, or object 2 equal object 1, object 2 and 1 both will be referring to the same memory, right? But we don't want to do this here, because simply we want center to be independent of the C. We just want to take the values, right? This is why this should be the right way to do it, right? Will this make center equal, like center to get x, center get y equal to the C to get x? Yes, it will make it equal, but not separate in the memory, and that's the problem, right? I hope this this explains to you what I mean by this. If you got questions, please ask. So this was one method. The second method, just briefly discuss it again. I simply refer to the center object, which is a member of my circle. I use the set x, set y that we have done in the previous lectures to get the values also for the C and Y. So I use get x, get y from one object to read x and y, and then set x, set y in the other object, which is the output one, to set the x and y values for the center. Questions?
Can I ask a question?
Yeah, go ahead.
Like, it just doesn't make sense to me. Like, you are letting a method to equal to x. Does it work in Java? Like this center.setX.
Oh, you're really correct. That's correct. Sorry, I was just thinking in the idea rather than the syntax. So you are completely correct. I mean, set x is simply taking an input, like an int input, which is x, and in this case you can write it like that, right? Another way to write it, if you feel like passing a function return to another function may seem complex, this is exactly as like this, which is, you can say int, I'm going to call this my x for now, just to avoid the complexities of this, and then say equals c dot get x, and then say this dot center dot set x equal my x, right? This is completely equivalent to this line, but I have just done it in one line, right? So this is completely equivalent, and I will leave the y the same. So does this answer your question, how?
Yeah,
good. Danny, can you explain what you just said again about the second way why it would be different? Could you say this to center equal new C? Yeah, Sarah, unfortunately, you cannot do this because simply C is an object, not a class. So you cannot say new object name, right? I see what you are thinking of, which is, can we really create another memory for the center and assign the values for C on the same line? No, you cannot do this. And then Danny, with regard to your question about the second method, simply the second method was to say this do center equal, or let's just write center directly, equal C, right? So this, we have seen some examples about this line in previous lectures, which is assigning an object to another object, and we said, or a reference to another reference, and simply we said this doesn't create new memory for center. This makes center point exactly to the same memory as C is pointing to, right? And this is why we don't want to do this. We just want to copy the values from C into the center memory space, right? Sagnan, is there a problem with line 37? Yeah, that's also the same thing. Yeah, for sure. Yeah, you are correct. And I guess, I didn't write the Y. Yeah, that's correct. Yeah, sure. Yeah, that's my bad. Sometimes I focus more on the logic, but you guys are completely correct about the syntax. Set x takes int as an input parameter. That's correct. Good. Any other questions?
Yeah, so just to be clear, doing center equals C technically gives us the correct value, but it's undesirable because they're both assigned to the same memory.
Exactly, okay. Correct. Yeah. Which means if C is modified outside of the center of the circle class, center will really be modified, and this is something that you don't want to do. Yeah. Okay, good. So if I go back to the slides, so just to visualize, let me do that. And then what we have done is the following, right? This is really what is class composition is. This is your circle class. Inside it, assume previously we had the point class. Inside the circle class, you have an object which is center that is simply a copy. Any object is really an instance of or a copy of the class point. And if you want to access X and Y inside this center, now you need from the circle class, you need to go inside two boundaries, right? The circle and then the center. This is why we said this dot center, which takes you inside this box, and then dot get X, right? I hope this kind of clarifies this statement for you, because now you have two boxes inside each other. The circle class, which is the outside one, and the object center, which is a copy of the point class. Good. Do we need to import a class into another to use its functions? So we will come into the importing right now, Sagnan, but simply assume point and circle are both on the same folder or package using Java terminology. You don't need to really import anything to be able to use the point class, right? And we have seen this also in our previous examples where we use the point class inside the main without any import. Good. So now the thing that I wanted to jump into before we discuss the sitters, which is we want to write some methods, right? And this method is we want to write this is tangential. Let's see, where is that? This is all explaining what we just discussed. Okay, all of this is, yeah. So now I assume I want to write one method because this is the last step you would write in a class, right? The methods of the class. So similar to the distance to for the point class, I want to write a method called is tangential to, is tang2. And this is checking whether two circles are tangential to each other or not. Just to refresh your mind about geometry, when two circles become tangential, you have two conditions or two cases, two scenarios. The first one is they are tangential from outside, or the second one is they are tangential from inside, right? So in the first case, how to determine whether they are tangential or not? Simply the distance from the center to the center has to be equal to the radius 1 plus radius 2. If they are tangential from inside, then the distance from center 1 to center 2 is really the difference between R1 and R2, right? So here is the summation. Good. So this is the definition of two tangential circuits, just to see how circuits, how to write their how to write the code for this function. Similar to the distance to, another application of why you need, if you have two objects, you can use the this members, but you need another one, which is the one that we have done for distance to. Now we call this C. So what I can write is simply, first of all, I said, oh, I should have kept this to use it to explain, but let's say, okay, so let's focus first of all in the simpler case, which is from outside. Simply, I want to do two things now. The first one is calculate the distance between centers. The second one is sum the R1 and R2, radius 1 and radius 2, right? So how to calculate the distance between the two centers? Any idea? I guess you already have it here, but let's discuss. How to calculate this distance? What do you think? First of all, center is an object of class point. This is also get distance between points. That's correct, Mark. But how to do this, right? Do I have to re-implement it? Yeah, Katie, exactly. That's the point. These two centers are really objects of the class point. Last time, we implemented a method called distance2, which we can reutilize to be able to calculate this distance, right? And this is what we do in this line. Simply, we say the distance equal to center, which is my current center, the distance2, and then I pass c to center as an object to this function, right? So now you can see the code reuse that we are doing for the point class. Then it remains to check the condition, whether this distance is equal to the summation or the difference, right? So here I have, this logic might seem complex, but simply forget about tolerance for now. So I can write it in this way. I can say math.absolute is just taking the modulus or the absolute value. I can say whether the distance, so I can write it in this way, distance equal radius You know what? I should just go to the code and write it. Okay, so simply, first of all, I'm calculating the distance between both. So I say center dot dist2. I hope I remember whatever the logic is. Let me see. Distance 2, okay. Distance 2, and then I'm passing the other point class, which is c dot center, right? Good. And then, oh, one question in this line to you. Center is a private, if I go up here, center is a private member of the circle class. How am I able to access it like c dot center in the is tangential function, or passing it like this in the distance 2? Is this correct, or are we doing something wrong here? And if it's correct, why it's correct? So simply the question is, center is a private member. How can I directly access it, say c dot center? You're still in the circle class, so it's okay, Katie, exactly. This is what we discussed last time, which is as far as you are implementing a method, which is a member of a certain class, it's fine to access the private members of that class, right? Even if you are referring to another object, which is C here, good. And we have seen this in the implementation of the distance2 method itself, right? Good, so here we are calculating the distance. It remains to calculate the, like to check whether the distance is equal to the summation or the difference between the two radices. So let's do this condition now, different than the slides. Let's say if distance equal to math dot, I might really don't need the absolute for the first one because the radius will be positive anyway, c dot. Now I want to refer to the radius of c, so I can directly write radius, or I can say get radius, but as we will discuss right now, it's okay to say c dot radius. Or the other condition, which is the difference, let's say dist equal, here I math dot absolute because I need to take the absolute or the modulus difference between them, and then say radius minus c dot radius. Good. So if it equals to the summation or the absolute difference, then those two circuits are tangential. So I'm going to return true. Otherwise, I'm returning false. By the way, doing this or say else return false, both are the same. Why that's the case? So why writing else or not writing it doesn't really make a difference? Can someone let me know? Because this is something that you really had in the exam, and I wanted to make sure you all understand. So why I'm saying else here is optional. What do you think? Why no different, Yan Hao? If it hits the first return, it exits, it doesn't go to the second. Rafi, that's exactly correct. So simply, if we come to this line, which is after the if, that means you never hit the if condition, because if you hit the if condition, you return, right? Which means if you are here, it's for sure the condition is not met and you are just returning false, right? Good. Perfect. So this is how you implement the is tangential to method, and how to use the center and the methods of the center inside the point class. Is there any question? Yeah, the same thing for C as well. That's correct. Okay, it seems no questions. So let me go back to the slides. So the slide implementation is slightly different. It just makes, well, it makes it more, I would say, reliable or resilient by saying I'm defining a tolerance error and then I'm checking if they are equal, but there is some tolerance error, I'm fine with it. But it doesn't really matter. You don't need to care about this for the example, right? Good. So what else? Yeah, so another thing we want to discuss in this lecture, let me see how much time is remaining. Okay, good. So another thing we want to discuss in this lecture is really so one thing we mentioned about constructors is you are not able to invoke the constructors at all, correct? But then when the constructor is getting used, what do you think? If I'm not able to call the constructor, that means it will never get executed, right? So when the constructor get executed, if ever, what do you think? When you make an object, exactly. So when you create an object, the constructor get called by default, right? And we said this multiple times before. Now, I'm going to give you one small exception to this, which is really you can call a constructor, but under a very specific limited condition, which is you can call a constructor inside another constructor, right? And the way you would do it is assume, for example, in the point class that we wrote, so we had two constructors back then, one that takes one that takes two input parameters, the other one takes one. And let's say I'm lazy enough to just say, okay, here instead of saying I'm setting A and A, can I just call the other constructor? And in this case, yes, you can call a constructor inside another constructor by using the reserved word this, right? Because this is the class name, right? So if I do this, which is this AA, it just simply calls the constructor of the point class that takes two input parameters, which I'm calling inside the one that takes a single input parameter. So what is the rule here? The rule here is you will never be able to call a constructor except from another constructor of the same class, right? Why we are bringing this here? Are we just bringing complexities for no reason? Really not. We will see what is the benefit of this when we come to inheritance later in the course, because you can really play around with constructors of child versus parent classes, right? So just for now, know that the rule is you can call a constructor inside another constructor of the same class. This is a condition. And the way to do this is to use the reserved word this. Good. Is there any question? Someone was, I guess, in the chat was asking about inheritance. So far, we didn't do anything related to inheritance. Let me see, what is this question? I'm not sure, but guys, please check, like, make sure you write question in front of your. Anyway, so far we didn't do any inheritance. The terminology that explains the relationship between the point class and the circle class is not inheritance, is really the composition, the thing that we were discussing, where the circle is one class and then it has a member that is an object of another class. This is not inheritance at all. This is class composition, which is using a class inside another class, right? Okay. Is this the same as inheritance? Not at all. Yeah, as I was explaining right now. And when we come into inheritance, Darsh, thanks, AK. Yeah, when we come into inheritance, we will see really what is the difference. Like simply here, we didn't touch the point class at all. And the relationship between the point class and the circle class is that circle only defines an object of point. It doesn't have direct access to the class itself, right? So as if you are just reusing the class normally, right? Simply, if you take it down or narrow it down, it's like using the point inside the main, right? Here I'm using it inside another class. Really, if you remember, we said also the main class is a class on its own, right? Okay, Julie, so what is this AA? So the rule is you will never be able to call a constructor from anywhere except one and only one condition, which is calling the constructor of a class from another constructor of the same class. How to do this is simply use the reserved word this. If I go back to the code just to show it to you with another example, here we have two constructors for the circle. One is taking RXY, the other one is only taking R, right? Something I can do instead of writing this is to say this and then send R and then 0 and 0, and that's it. So this is exactly the same code. Why that's the case? Because this is referring to the current circle class, right? What is the constructor? Excuse me. So what is the constructor that is taking 3 input parameters? It is this one, right? Which means I'm calling this one right now. I'm passing R as R here, and I'm passing 0 and 0 for X and Y, right? This is how simply you call a constructor from another constructor. Correct, Yanhao, that's correct. Okay, perfect. I guess because I have another full screen going on. Okay, good. So what else? So now, given that we discussed the point of assigning a class to another class, what are the operations, or object to another object? What are the operations we can do on objects, right? The first one is assignment. For example, I can say an object equal null to just nullify this object, it refers to nothing, or make it refer to a certain place in memory, or assign an object to another object, similar to what we said, this do center equal C. This is also assignment, right? Typecast, and forget about typecast right now, we'll visit it later for inheritance. We can also check the equality and non-equality of objects, and we will have in the next slide an example about this. Dot operator is just the straightforward one we have been using all over. It's simply referring to certain members of that object. In our code example, for example, we say center dot get x. This is one example of the dot operator. The rule here is you cannot use the dot operator for an object that is null, because simply it doesn't have any members. That's well known. An instance of is also another thing we discussed before, which is you cannot check whether an object is an instance of a certain class or not, right? And again, we will use instance of a lot when we come to inheritance. Good. You cannot do any direct math operations on objects, because these are objects, right? These are objects of classes that have multiple values. You cannot just add or subtract these, right? So let's like discuss some. All of this is almost not new except for the equality and checking and non-equality, right, for objects. So let's check that right now. Assume I define 3 objects right now, B1, 2, 3, saying B1 equal this value, 2 equal this value, and then 3 equal this value. And then let me say I check whether B1 equal B2. What do you think? Does this give you true or false? And why? You cannot have snake there. You cannot have 3 constructors with the same input parameters, because as we discussed in the overloading lecture, the only way you can have methods in general, or even constructors specifically, with the same name is you have to have different number of input parameters, right? False, 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 false. Why false? What do you think? What is the reason that to get false? Yes, you are correct. And the trick here was that everything has the same value, but why false? It compares addresses, Carter. Perfect. That's correct. Because if you look into what happens in memory, we call these objects references, right? And we, in the first lecture, we said you can deal with them as pointers, right? In the ones that you know from C. So for B1, I'm creating a new object in memory and making B1 point into it. In the second line, I'm creating another place in memory. I'm making B2 point into it. Here, I'm assigning X of this to B2, Y of this to B4. Here also X is 2, Y is 4. What I'm checking here is really whether B2 and B1 are pointing to the same place or not. And as you said, the answer is false, because these are 2 different objects. What about, I would say, B3 equal B1? What do you think? True. Perfect. And the reason for this is B3, by writing this statement, we are making B1 and B3 pointing to the same place in memory, which means if you check, both will have the same address. Correct. So guys, you get the rule, which is checking equality or inequality here is more about addresses, not values, right? So it's like pointers in C. Pointing to the same memory. Correct. Good. Okay, so all of this is good. The other thing, and this is just a review, we're just putting the rules we have been through in the previous lectures together. What are the access levels of classes? We have seen public classes, and this you can access from anywhere. Point class was public. I was able to access it in the circle class as well as the main. If you have no modifier at all, so you just write nothing, not public, not private, then you can access only within the folder, within the package, but you cannot access from outside. For members, you can have a member as public, and this is something we discussed when we discussed the interface of setters and getters. We started by having X and Y to be public, which means they are accessible from everywhere. If you remember in Point, where X and Y were public, I was able in the main to write point.x and point.y, right? And then we said later, this is not a good behavior, then I should forget about protected for now. We will have a lecture about it. But then we said we want to assign them as private, which means we cannot do this, and you need to do the setters and getters, right? And then the other thing is, if you have no modifier at all, not private, not public, then you can only access them within, again, the same folder of the project, right? This same folder of the project we call package in Java, but that's the terminology, right? Java organizes things in a folder hierarchy, right? So if you have all, and this is one reason why we didn't need to import the point class. If we go back to our code again, here I had 3 files, main, point, and circle, and I was able to use the point inside the circle here, for example, here, without importing anything. And what is import? Similar to include in C. Why that's the case? Because all of these by default are in the same folder. A folder in Java is called a package. So between a package, you don't need to import anything. While if you have something in another folder, or in Java terminology, in another package, or in another project, then you would have to say import either like the package name dot point, or like the folder name dot whatever class you want to access. Good. So is there any question? Yanhao, if I compare the attributes of an instance, does it compare their value or their addresses? No, here by doing this, you are comparing. So getX is returning an int value. So here you are comparing an int with an int, which is the value itself, right? Good. Sarah, how would you check the values? I mean, similar to what Yanhao was saying right now. Like if I want to access certain values of an object, I have to use the getters, get the values, compare them with another object values, also using the getters. It's exactly the same example that Yanhao is giving on the chat right now. Good. So by this, we conclude. The last thing I want to show you, which is a little bit application on what we do in the lab for class composition. It's really not class composition, because if you look into, in the lab, we have 2 classes, right? Matrix and upper triangular matrix class. In the upper triangular matrix class, we really don't define an object of the matrix class itself, right? So it's not really a 100% class composition, but in some of the methods, if you start working on the lab, for example, here, this full matrix thing, this full matrix method of the upper triangular class is really constructing a matrix class. So matrix here is the other class, right? So you are working on one class object, which is full in this case, inside another class definition, which is the upper matrix class, which is again another form of class composition, right? And you'll see these examples like a lot in the lab. I don't think the upper triangular is used in the matrix class, but let me check here. Yeah, that might be the clear example of operating on a matrix. Yeah, I guess maybe also in the constructor. Yes, in the constructor, one of the constructors of the upper triangular matrix is taking an object of matrix class, which is again another form of using a class inside another class. So by this we conclude. So thanks everyone. You guys are free to leave, and I will remain for a couple of minutes to take questions. Yeah, this author thing is yeah, forget about it. It even has the wrong name because I copied it from an old implementation of the lab. So yeah, it has nothing. It's just a comment, right? So you can remove it. No worries about that. Question: after I extract the Java package and click on the Eclipse icon, it shows a JRUJK must be available. No Java virtual machine was found after. So okay, so if you look into the video, but I did include Java bin into path. It's because my Java JDK was installed in E drive. No, that's if you added no, that's not that. No, that's not possible. I guess also in the document I gave, there is a way to check whether really your system is seeing Java or not, right? So what you can do, forget about Eclipse for now. If you added the path into your system variables, You can open a command line, type, I guess, Java-version. It gives you the version if it knows the word JDK. If not, then you didn't add the path correctly. Oh, Rafi, I checked today almost, I went back to almost every email and I made sure I respond. So if I didn't respond to you yet, please, yes, email me back again, because yeah, for some reason I might have lost your email, because today I went through all the emails back. Some of you might have already received a response from me. And by the way, all the grades are updated for those that need an update. Both those who got extra marks and both that lost marks as well. Krina, make sure you change the path after downloading it. Mine did that. Okay. How can I make a Java project with files so I can practice Java in Eclipse? What are the steps in Eclipse? I need folder, then Java files in it. So simply what you have done in C is exactly the same thing. Make a new project in Java. It gives you an empty project, and then you can operate on it. You don't need to set it up. It's simply just create a project in a folder, right? Okay, good. So if there is there any other, okay, file new, and then, yeah, that's the case. Okay, good. So thanks everyone, and I guess I will, oh, by the way, I forgot to say, there is no tutorial. So I have already posted this announcement on Avenue. We don't have a tutorial this Friday for some reason. But what I can do is I will post some practice questions as well. You guys have my video for the lab. I guess it should be helpful for both the environment setup as well as the technical questions of the lab itself. If you got questions, please use the office hours for this. This is the best way to get a prompt response, right? And thanks everyone, and see you all in Friday's lecture.
1 second.
Yeah.
I just get interrupt for the last minute. May you remind me, what did you talk about the up triangle matrix stuff?
Yeah, so for the upper triangle, I didn't say anything except that in the upper triangular matrix, we are using the matrix class itself. This is a form of class composition that we were discussing this lecture, right?
Oh,
Here, for example, in the constructor, we are passing an object of the matrix class, right? So I was just trying to connect the lecture with the lab, right? So and how I guess you are talking, but I don't hear you. So you guys do hear me well? Okay, for some reason I only hear noise. Okay, am I back right now?
Yeah.
Okay. So the problem was in my side then. Yeah. So Yanha, what I was saying is I was trying to connect the lecture with the lab. So simply to show you some form of class composition we do in the lab, where in the upper triangular matrix, you deal with objects of the class matrix, which is another class, right?
I see. Thank you.
Welcome.
And, oh, yeah. Never mind.
Are you good?
Yeah.
Okay, perfect. Is there any other question? Okay, good. So thanks everyone, and have a great day, and I will see you all in on Friday then. Bye-bye.